Today we're going to focus on solving quadratic inequalities. So instead of linear inequalities, these are going to be quadratics where the variable is going to be to the second power. So again, when we're solving quadratic inequalities, there's steps kind of to follow, right? So if you get an inequality, less than, greater than, whatever, you're going to have to set it equal to 0. Okay, so you want to make sure that everything's on, like, let's say the left side, 0's on the right side, and you set it, take away the inequality symbol and solve it as if it was an equal sign. And then what's going to happen is we're going to identify our solutions by picking test points. So I'll show you what I mean. So let's just start here with this problem here, this first problem. So it says x squared minus 2x minus 3 is less than 0. Notice that everything's on the left, there's 0 on the right. So what we're going to do is we're going to start out by converting this to an equation. We're just going to make it equal to 0. And then we're going to factor this left side. So x minus 3, x plus 1 equals 0, which means x is 3 and x is negative 1. So these are two solutions, right? However, notice that this is an inequality, and so this isn't just going to be two solutions, it's going to be a range. So what we're going to use those solutions for is we're going to go and create our number line, and these solutions are going to partition our number line into, into different sections. So basically here's negative 1, here's positive 3. And then notice that there's 3 sections to this number line. There's, let's say, section 1, there's section 2, and there's section 3. Okay, and our solution is going to be in some of these ranges, and we got to figure out, well, how do we do that? How do we figure out what area our solution is in? Well, what we're going to do is we're going to pick a value within one of the sections, and we always look to see where 0 is. And notice that in this graph, 0 would be in this section here, this inside section, right? Between negative 1 and 3. So I'm going to plug 0 into my original equation or inequality. And you might say, well, why pick 0? Well, because the math is so easy when you pick 0. Because if this is 0 squared, it's just 0. If this is 2 times 0, it's 0. And so notice that it's super easy to do the math, and you get left with negative 3 is less than 0. Now you ask yourself, is it true or false? Well, negative 3 is less than 0. This is true. That means that the section where 0 falls is every value in that section is going to be a solution. So think of it as negative 1 and negative 3. Break this up. All the values between here work. And if the value there works, the values on the other two sections on the left and right of it do not work. Okay, solutions kind of go in alternating patterns. And so we know then that our solution is going to be, notice this is a less than, so it's going to be between negative 1 and 3. It's going to be all these values in here. And so in interval notation, my solutions are from negative 1 to 3. And that's the answer. So let's do some more, and you'll see how it becomes easier and easier. So again, here we notice it's less than 0, so we can just make the whole thing equal to 0. We're going to factor, this is x minus 3, x plus 2 equals 0. So x is 3 and x is negative 2. So we know, we have here our drawing, right? We know that we're going to have negative 2 and we're going to have 3. And so again, these are 3 sections. The sections to the left of negative 2, the one in between negative 2 and 3, and the one to the right. And 0, we notice, falls in this section. So we're going to plug 0 in. So again, 0 squared cancels, minus 0 cancels, and we get minus 6 is less than 0. And once again, that's a true statement, which means everything in here is a solution, and to the left and right are not. Because it's a less than, I know it's going to be an open circle, and it's going to be everything in between. So in interval notation, this answer is negative 2 to 3 with parentheses. And so that's how we solve it. Down the road, we'll graph it, and you'll see what that would look like in a graph. But for now, this is all we have to do. So again, we're going to go here to number 3. Notice that it's, again, equal to 0 or greater than or equal to 0. So we're going to turn it into an equation that equals 0. We're going to factor x minus 5, x plus 4. So x equals 5 and x equals negative 4. So again, I'm going to come over to my graph. I've got -4 here, +5 here, and again, 0 falls here in the center. And so I'm going to plug 0 in. When I plug 0 in, these two will cancel, and I'll get -20 is greater than or equal to 0. And this is false, which means the section that includes 0 is not a solution. So what are solutions? The one to the left and the one to the right. Now, because again, this is a greater than or equal to, now I know I'm going to have a filled in circle, right? And it's going to go that way. And I'm going to have a filled in circle here, and it's going to go to the right, to the areas that I checked off. So my solution to this problem in interval notation is going to be, again, remember that it's -infinity to -4, bracket, parentheses, union, right? And then it's going to be 5 to +infinity, bracket, parentheses. And so that's the answer in interval notation for that problem. Okay, and then we go to the last one. And the last one, again, we see the zeros on the right, so it's perfect. So we're going to do 4x squared minus 5x minus 6 equals 0. Again, I got a factor. A is 4, so it's a little bit tougher. What numbers multiply to -24 and add up to -5? Well, that's -8 and +3. So I've got to turn this into 4 terms. -8x plus 3x plus -6 equals 0. GCF of the first two. GCF of the second two. And so my GCFs get canceled out there, become a term, and then 4x plus 3 equals 0. So x is 2, and when you do all the math here, you're going to get 4x plus 3 equals 0, 4x equals -3, and you get x equals -3/4. So I have these two values. So these are my borders, right? So I'm going to come over to here, and I know that I'm going to have -3/4 and +2. And again, 0 falls here in the middle, okay? So I am lucky about that. So I'm going to try 0. So when I try 0 here in this problem, this is going to cancel, this is going to cancel, and I'm going to get -6 is greater than 0. And again, that's a false statement. So I know 0 is not included, so my answer is in the other two regions. Again, I'm going to look at the greater than symbol. It's not equal to. So I know that in this particular scenario, then I'm going to have an open circle at these two values, open circle this way, and open circle and go that way. So again, how do I write that in interval notation? Well, I'm going to go from -infinity to -3/4, oops, nope, not parentheses, parentheses here, oh yeah, and parentheses here, union, and then I'm going to have 2, and I'm going to go to +infinity, also parentheses. And that's how I write that out. So we're going to just keep doing more and more practice with this. Now here, notice that it doesn't equal, it's not equaling 0, right? So I'm going to have to move the 12 over. So I'm going to end up getting, first of all, let me just distribute that, right? So I'm going to get x squared plus x, and then I'm going to do -12 is less than 0, right? Do that. Now I'm going to make it equal to 0. And then I'm going to factor. So x plus 4 times x minus 3 equals 0. X equals -4, and x equals 3. So when I come over to my graph, I know that I'm going to get a -4 and a +3. And again, 0 falls in this middle section, which is great. So when I come back to the original problem, and I say 0 times 0 plus 1 is 1 is less than 12. Is 0 less than 12? Yes, that's true. So because it's true, I know that the center is my solution, and so these are not. And so I look, it's a less than, so I know I'm going to have an open circle at 4, an open circle at 3, and my graph would go in here. In interval notation, how I would write this again is from -4 to 3 with parentheses. And again, let's go to this last problem here. We've got x squared is greater than or equal to 16. So there's a couple of ways to do this one here. I can either, do x squared minus 16 is greater than or equal to 0. Then I turn it into equals 0, and I get x minus 4 times x plus 4 is 0 because it's a difference of squares, which means x equals 4 and x equals negative 4. So I could have gotten it that way. I could have also seen that this was a perfect one to solve using square roots. I could have said x squared equals 16, so square root, x equals positive minus 4. Either way would have given me those two values, right? So again, I'm going to come over to here. I've got minus 4, I've got plus 4, and so I'm going to try again 0. So when I try 0 here, 0 squared is greater than or equal to 16. That is false. And since this is false, then I know wherever 0 is not the solution area. So that means these two sides are. Because this includes an equal sign, I know it's a filled in circle to the left and a solid circle to the right. So in interval notation, this would be negative infinity to negative 4, bracket, parentheses there, union, and then 4 to positive infinity, and again, a bracket. So it's pretty straightforward, pretty easy. Now we're going to start to get to a little bit harder problems. You might find here that we may have some problems that might not be factorable. So let's see like what we would do with those special cases, right? So again, we come to this problem here and we're going to start out by moving the 1 over. So x squared plus 4x plus 1 is greater than 0. And then we're going to set it equal to 0. And so we start asking ourselves, well, what numbers multiply to 1 and add up to 4? And there aren't any. And so this, unfortunately, is not factorable. So now you say, well, how am I going to solve it? Well, some of you may choose completing the square, and some of you may choose quadratic formula. I personally, because A is 1 and B is even, I'm going to move the 1 back over to here, and I'm going to use completing the square. So I'm going to take half of B, which is half of 4 is 2, and square it, which is 4, right? So this side's going to become x plus 2 squared equals negative 1 plus 4, which is 3. And I'm going to take the square root of the left, positive and negative square root of the right, and I'm going to get x plus 2 equals plus minus radical 3, and then subtract 2 from each side. So my answer here is x equals negative 2 plus or minus the square root of 3. Now, when I go to this number line here, right, I know that minus 2 minus the square root of 3 is going to be on the left, and minus 2 plus the square root is going to be on the right. However, what I don't know is where does it fall? Like what number value is that, right? Is that going to be, where's 0? I mean, I know 0 is not here, but is 0 here or is 0 here? So I'm going to have to kind of have an idea of what the value of negative 2 plus or minus whatever is. So the square root of 3 is about 1.7. So if I do negative 2 minus 1.7, I'm looking at minus 3.7. So this is about minus 3.7. And if I do minus 2 minus 1.7, this is going to be about minus 0.3. And so I realize that 0, okay, falls on this right side, okay? So again, and that's important to note, right? So let me kind of move this out of the way now, but we needed to know that value. So now if I plug in 0, that's absolutely fine. I come over to here, 0 cancels this out, so it's 0 is greater than negative 1, and that is true. So the side that includes 0, or the section, is definitely going to be a solution. And so again, if it's that one, then remember it alternates. So this is a no, and this is a yes, okay? So this is a less than, so it's an open circle this way, open circle, and that way. So my solution is going to be, again, negative infinity to negative 2 minus radical 3, parentheses, union, and then it's going to be minus 2 plus radical 3 towards infinity that way. And so, again, just be careful with those square root values. Again, you can write them as radicals, but you do have to kind of have an idea of where does 0 fall in relation to them. Okay, and then this last one, notice that there are 4 terms here. So again, you're going to do what you normally do when you're solving any quadratic, is you move everything over. And actually, this is not really even a quadratic, right? This is a 3rd degree. So let's see what happens. We've got 2x cubed minus 3x squared minus 32x plus 48 is going to be greater than 0. Again, once we do this, we're going to set it equal to 0. And because there's 4 terms, we're going to have to solve here by grouping. So the GCF of the first term is x squared, or the first group. So that's going to be 2x minus 3. The GCF of this one is going to be 16, which is going to leave us with 2x minus 3. Again, the GCF here, 2x minus 3. And x squared minus 16 equals 0. So now I have to kind of factor each one of these, right? So, or not factor, but solve. So 2x minus 3 equals 0. That means 2x equals 3, which means x equals 3 over 2. And then here, x squared minus 16 is 0. I can do this a couple of ways, but this is x minus 4 and x plus 4. So I know x is 4. And x is negative 4. So this one was kind of weird because remember, it's a third power rather. So we know there's going to be 3 solutions. So now when I do my number line here, this is the first time we've seen this. We're going to have negative 4 here. And then we're going to have somewhere along the way, we're going to have 3/2. And somewhere moving to the right, we're going to have 4. Now we know here's infinity and here's negative infinity. So obviously we've now broken this up into 1, 2, 3, 4 sections, right? So again, we're still going to do the same thing. We're going to try to pick an answer that falls in one of the sections, right? And so like we talk about a million times, 0 is really a great one to use. So 0 we know falls in this section here. 0 is in this part. It's between negative 4 and 3/2. So let's try 0. 0 would cancel this one out, cancel this one out, and cancel this one out. And we would get that 0 is greater than negative 48. And that is a true statement. So we know that 0 is a solution. Now remember that the solutions alternate. So if 0 is a solution, the one before it is not, the one after it is not, which means then this one would be. And so that's how you do it. You just have to find one section. If 0 happens to be one of the solutions like here, and so you're like, oh, 0 is actually on the line, then pick the second best, easiest number, which would be +1 probably, okay? But whenever 0 is not one of these section makers here, right, you definitely want to pick it, okay? So again, and then if I was to write this, right, I know that my interval notation is going to be pretty messy, right? This is going to be open circles, right? So let me do it in red. So I'm going to have an open circle here, and it's going to go this way. I'm going to have an open circle here, and it's going to go this way. I'm going to have an open circle here, and it's going to go that way. So when I'm writing this, notice that my leftmost solution is -4, and it goes all the way to 3/2. Neither one of those is included. Notice the open circle, right? And then I'm going to get another one here that starts at 4 and goes to infinity. And so that's how I would write that down. Okay, those are my solutions for this problem. All right, that's it for today.